In this video, we are going to learn how to interpret and use vertex form. So for each quadratic function, what are the vertex, the axis of symmetry, the maximum or minimum value, the domain, and the range of each of these quadratic functions on the left. So this is how you interpret vertex form. So in a previous video, I went over how to find the vertex axis of symmetry, but I'm going to give a quick reminder as we go through this first example. And here's vertex form on the right, so we can compare. So the vertex is always h comma k. So in this case, my h is a positive 4, because again, it's whatever you're subtracting from x is h. In this case, we're subtracting 4, so it would be a positive 4. And then whatever you're adding on the outside, but in this case, it's minus 2, so we're adding negative 2. So our vertex is 4, negative 2. So we know where that bottom point of the function is now. Now our axis of symmetry is always goes through our vertex, but through the x value of our vertex. So since we know our vertex is 4, the axis of symmetry is x equals 4. Now, the a value is a positive value. So since a is greater than 0, the parabola opens upward. So now that we know that it opens upwards, the k value that we have, which is negative 2, is going to be the minimum value. Because since we know that it opens upward, it'll be the lowest points, the vertex. So that will be the lowest value, a minimum. Now domain, the way we read domain is, okay, are there any x values we cannot plug in? Now, I can subtract 4 from any x value, and after subtracting 4, any number I get, I can definitely square. So my domain for this function happens to be all real numbers. And that's a little shortcut to writing all real numbers. That's called a bold R. But now the range isn't all real numbers. From what we remember about these functions, they always have a bend to them, meaning there's a lot of y values we don't use if it opens upward. So if we know that negative 2 is the minimum value, that means that we're only going to get y values that are greater than or equal to negative 2. And that would be the range. It means we'll never get negative 3 as an answer, since we know our minimum value is negative 2. Let's look at this next example. So we have a here is negative 2. H is actually negative 1, because if I were to rewrite this to make it look like vertex form, when I subtract on the inside, make it that plus 1, I would be subtracting negative 1. So that's why we can tell that h is negative 1. And then we are adding 4 on the outside. So our vertex for this quadratic would be negative 1 for h, so negative 1, comma, positive 4, because that seems to be our k value. Our axis of symmetry is x equals negative 1, since we're going through our vertex. And now we're trying to figure out if we have a maximum or a minimum value. And we will have a maximum value because since a is less than 0, the parabola opens downward. Which just means that k equals 4, since now it opens downward, is a maximum value. Now the domain still will be all real numbers, because there's nothing I can't add 1 to or square. So it should be every number can be plugged into this. There's no restriction on the x values. But the range now, instead of being greater than a certain number, will now be all less than a certain number, since I know I have a maximum value. All the y values are going to need to be less than or equal to 4, since I know that is my maximum value. So now that we know how to interpret these functions, we can use this information to help us graph these functions. That's how you use vertex forms. So we're going to find the graph of the quadratic function and describe what steps transform the graph of y equals x squared, the parent graph, to this given quadratic function. So first, I'm going to note that my vertex is 1, 3, and my axis of symmetry is x equals 1. So 1, 3. So 1, 3. And my axis is x equals 1. This will help me graph, because now that I know where my axis of symmetry is, I only need a point on one side of this to get a point on the other side of it. So if I were to pick this x value at 2, and plug 2 into my function, I should get a y value, and then I can just reflect that point across the axis to get another point. So we have y is equal to negative 2 times 1 squared plus 3. So negative 2 times 1, negative 2 plus 3, y is equal to 1. So at 2, 1, we have a coordinate, and if I reflect that, I have another point at 0, 1. So now I can clearly see that my graph is a downwards facing parabola right there. Very quick to graph. You only need one more point. Sometimes you can go up to 2 more points to get very accurate, but at least one, just so you can create that parabolic shape. Now let's describe the transformations that took place. And we're going to start with what we multiply by. So here we have this negative at the front. So the first translation is a vertical reflection, since a is negative. So vertical reflection across the x-axis, because if it's vertical, it goes across that axis. And then you'll see here that the absolute value of negative 2 is 2, so we have a vertical stretch by a factor of 2. Because the negative, I don't need to put negative 2 because the negative is already accounted for in the reflection. And you'll see here that we've shifted to the right one, so translation right 1 unit. And lastly, we have a translation up 3 units. So now we're using this vertex form to find all of these transformations, as well as help us graph, and we can get a lot of information out of just one equation. Now let's try this one more time so you can really bring together everything that just happened. So again, vertex, h is negative 2, y is negative 5. And the axis of symmetry is going to be at x equals negative 2. So I'm going to graph my axis of symmetry first. Then my vertex is at negative 2, negative 5. So 1, 2, 3, 4, 5. And now I just need one more point. I'll pick 1. So plugging in 1, I get y is equal to 2 times 1 plus 2 squared. So that's be 3 squared. Oh, sorry, I should pick negative 1. Yeah. 1 goes way to the right. I just want to go 1 to the right. So that would give me 1 on the inside. So negative 1 plus 2 is 1 squared. So it would be 2 times 1 minus 5. So y is equal to 2 minus 5. So y equals negative 3. So we're at negative 1, negative 3. We can reflect that point across the axis of symmetry, and now we have our parabola. So relatively quick. Now describing all the transformations, there's no vertical reflection this time, but there is a vertical stretch by a factor of 2. Just like before, the absolute value of 2 is 2, so you'll see that these graphs have a similar level of steepness to them, but one's reflected and one isn't. And we have a translation left 2 units. If you just follow that vertex, because originally it's at the origin, you can always count it, okay, it's left 2 and then down 5. So translation left 2 units. And a translation down 5 units. And again, just to reiterate that point I made, I know that the original parent graph starts at the origin, so I can just track where the vertex moves from the parent graph to the vertex of my new function. And that's also a way to find that translation. And that is how you interpret and use vertex form.